Hi teacher, this is my first exam of Mathematical Foundations course. I'm Jesus Gonzalez, and this is the exercise, one of the exercise that I choose to do my exam. Is the exercise number 46 of the 1.2 exercises. So the problem says a circle of radius 1 rolls along a coordinate line in the opposite direction, as shown in the figure. If point P, if this is initially at the origin, find the coordinate P after 1, 2, and 10 complete revolutions. Well, that I did for this problem, to solve this problem, was remember the formula to find the circumference of a circle. So we have here a circle, and if we take this circle that I'm going to draw right here, it's the same. Well, we can take the length of the circle, and this equals to, I'm going to write this circumference equals or is equal to 2 pi by radius. And our problem says that the radius of this circle is 1 unit. So it is really easy. This problem is really easy. So that we need to do right here, if we want to make it like if this were a physics problem or fixed for physics, sorry, we can make this. Our data says that radius is equal to 1, I don't know what, but 1 unit, that's gonna say. And that we wanna find the coordinate P after 1, 2, and 10 complete revolutions. So we only need to multiply or this result that we are going to obtain by 1, 2, and 10 to know what will be the coordinate in this line for our circle after 1, 2, and 10 complete revolutions. So we need to calculate this by replacing in our variable. It is going to be 2 pi times 1. So this is our circumference, so it is going to be equal to 2 pi units, and that's all, because this is 1. If, for example, this instead of 1 were, I don't know, 5, sorry, so then the result will be or would be 10 pi, but that's not the case right here. So with this, we are going to say that for one complete revolution, the coordinate will be 2 pi, and it should be something like here, 2 pi. This should be for one revolution. So we only need to make this like 2 pi is equal to 1 revolution. So if we wanna find for 2, we need to, we can do the simple rule of 2 root, and we're going to make this little operation that we're going to multiply, and after that divide by this. So for find x will be equal to 2 times 2 pi divided by 1. We can say that here are the units, revolutions. So we are going to do this. and we are going to have that for pi. This is going to be for 2 revolutions. And I'm going to write here that this one is for 1 rev. And 2 pi is for 1 rev. We want to find how much will be for 10. 2 rev. So this will be x. So x will be 10 rev multiplied or by 2 times pi over 1. Right? So our units will be erased or simplified to 1, and we are going to think that 10 by 2 pi is equal to 20 pi. Pi, units only. This will be for them 10 revolutions. So this line is too short to make this visual, but for example, if we take this, you will remember that here's the coordinate, approximately, that is going to be the coordinate that should be if this circle rolls 1 complete revolution. So give me a moment to write the other problem, and then after that I will solve it. Well, teacher, here's the other problem, and I'm going to read the problem. Oh, my mistake. This is from exercises 1.2. 100 body surface area. A person's body surface area, S, in square feet, can be approximated by this little formula. S is equal to 0.1091 times W raised to the 0.425 power by H to the 0.725 power, where height H is in inches and weight W is in pounds. So the first, for letter A say us estimate S for a person 6 feet tall, weighing 175 pounds. So here we have our first problem. I'm going to write again A right here, and I'm going to start with first of all our data. So which data does the problem give us? This one. How tall is the person? So we have that H is equal to 6 feet tall. But here we have the first problem, that this should be H in inches. So we must convert this. So here we have 1 feet is equal to 12 inches. So we must convert that. So 1 feet is equal to 12 inches. So 12 feet should be equal to x. So we can make a little rule to multiply by this, and after that divide. So I'm going to write it right here again. X will be equal to 12 feet times 12 inch over 1 feet. And like in the other problem, our units will be erased, and 12 times 12 inches divided or over 1, that we can take this because it is going to be divided by 1, so this is equal, it doesn't matter. So this should be 144. Let me look at that because, yep, I'm right. So 144 inches. So once that we have the result, I'm going to erase this, and I'm only gonna write that this is equal to 6 feet. So estimate S for a person 6 feet tall or 144 inches, weighing 175 pounds. So I'm only going to write, I'm going to erase this. So I'm going to write the formula again, and this will be pretty fast. W, so we need to replace this. We have 175 pounds, and weight should be in pounds, so it is okay. And 175 pounds raised to the 0.425 power times 144 inch raised to the 0.725 power. So I'm going to use my calculator to make this operation. So here I'm going to make this 0, only the screen of the, thank you very much, 0.1091 times 175 pounds raised to the, oh, it doesn't works, 0.425 power multiplied by 144 inches raised to the 0.725 power. So I have this in the calculator. I'm going to look at the, okay, it is okay. So we have that S should be equal to 35.96903016, and the problem says that this will be in square feet. So square feet. So for the first, we have that S will be equal to this square feet. So that is the first result. I'm going to write it pretty fast right here. S is equal to 35.96903016 square feet. Okay. So I'm going to erase again right here, and I'm going to write that this now is the exercise B. If a person is 5 feet 6 inches tall, we must convert again. So 1 feet, we say that is equal to 12 inches. So 5 feet should be equal to 5 times 12, and this is 60 feet per inch divided by 1 feet. So this is equal to feet. We have 60 inches. So I'm going to erase this again. And we have that this person is 5 feet, so 60 inches, plus the other one, well, the another 6 inches that we were missing. So inches plus inches, this is equal to 66 inches. So that is the tall of the person. What effect does a 10% increase in height have on S? So we are going to make this little procedure again. I'm going to write it pretty fast. 91 times W. Well, here the problem does not give us any specific weight for this. So one way to solve this problem could be that we are going to say, for example, that the weight of the person is 200 pounds. So we're going to say that this is the first weight of the person. And if we want an increase of 10%, because we want to know what happens if that increase is present, so we only need to do another simple calculation that it is pretty fast. 200 pounds, hurry up, Jesus, is the 100%. So 110% should be, and we are going only to make this procedure, but it is so easy, so we are going to say that this is 220 pounds. Yeah. So our second weight should be 220 pounds. Let me erase this really fast. I said that this tall is equal to 66 inches. So the only thing that we need to do right here is to replace the values of our letters and look at the results after we make it, well, after we solve it. So I'm going to write it pretty fast again. And for the first weight, so I'm going to write S1 should be 200 pounds raised to the 0.4425 power multiply or by or times h, and h, this is 66 inches raised to the 0.725 power. So I'm going to solve that. Well, in order to make it a little bit faster, I'm going to write the second equation right here, and this should be 0.1091 times 200 pounds raised to 0.425 power multiplied by 66 inches raised to the 0.725 power. So S2 should be equal to, I'm going to take my calculator right here. So 0.1091 times 200. Oh no, my mistake. Right here is 220 pounds. Sorry, 200 pounds raised to the 0.425 power times 66 inches raised to the 0.725 power. This should be equal to, I'm gonna to make it sure that it is okay. Yeah, of course that it is. So we have right here that the person has a 21.62379.184 square feet of surface on his body, or on, well, his body or her body, depends on the person. but it doesn't matter for us. So I'm going to solve this one equation. 0.1091 times 220 pounds raised to the 0.425 power times 66 raised to inches raised to the 0.725 power. It should be equal to, well, I think that I did a mistake right here. No, I'm okay. 22.51. Well, it doesn't seem like outcome. 0.5176859119. Sorry, I was going to say 19, but it is not mentioned like that. So then we have the comparison right here, and we can conclude that the thing that is going to happen right here is that if the weight of the person increases, or the surface of his body, the surface of his body is going to increase too. Why? Because if a person weighs more, it is going to increase the body surface area. So that should be let me write that on right here. That we can conclude that if the W of a person increases and the tall is the same, the body surface area will increase. So that is the answer for that. Well, it doesn't seem okay. T. So we have W and T. So we can conclude that if the W of a person increases and T is the same compared than if it were 200 pounds or 220 pounds, it doesn't matter. Well, it matters, but that is going to be the result of increased surface area of the person. So, thank you, teacher. I think that I explained a lot, and these were simple exercises. Right here I have the citation for the book or reference. So thank you very much. This was my first exam of Mathematical Foundations course. So thank you very much.